Alright, so as promised, I'm going to try the next proofs as two-column proofs instead. And these ones are a little bit messy. They're definitely a little bit more challenging than the ones that we did in class. And there is also more than one way to complete these proofs. So this is a sample solution, not the solution. So we are given that AB is congruent to DE, and we are given that AB is also equal to BC, and that DE is also congruent to EF. So we have basically everything is equal to each other, which is why we have options here. And our goal is to get AC equal to DF. What I do know right off the bat is that because we're dealing with larger segments, and we're dealing with segments in general, that this is a sum of the parts proof. And then I might need to be doing some addition, or if not, then definitely some clever substitutions. And that's the method I'm going to take, clever substitutions. So I started with AB is equal to BC. Given. We know that. And then I brought in the fact that segment AC, the top segment, was equal to AB plus BC. And the reason is the sum of the measures of the parts is equal to the measure of the whole, and that does not have a reference. Now, this is where my clever substitutions happen, and it's okay if you wouldn't have thought to do this until you watched this video. So I swapped out this BC and turned it into an AB, which we are allowed to do per step one. Step one says that they're the same thing. Then I said that DF was equal to DE plus EF, which we know. And my reason is reason 2. I didn't have to write it out again because I already wrote it once, and I'm just referencing that step instead of writing the whole thing again. Well, we know that DE is equal to EF. That was given. So I did some more clever substitution, and I turned this EF into a DE. Well, we happen to know that AB and DE, they're the same thing. That's given. Well, here's a bunch of ABs, and here's a bunch of DEs. If I replace one of them, and I chose to replace step 6, I said that DF was DE plus AB. I changed this piece. Substitution using steps 6 and 7, because those were the steps involved. I now have right here that DF is AB plus AB, and AC is AB plus AB. So I've said that they're the same. So I can end by saying AC equals DF, substitution. And I plugged, or substituted, steps 3 and 8 together to get that new statement. Now the other proof, I'm going to go through it kind of quickly, but here it is. A little bit shorter and definitely a little bit easier than the previous question. Take a look at it, and this one does do some substituting again and some subtraction. This is a lot like our subtraction proof from up above, but the only difference is I'm not subtracting the same thing from both sides. Letter-wise, I'm subtracting A, B, and DE, which is essentially the same thing. So I don't have the reflexive property. I'm given that blue equals blue. My other given says that orange equals orange. So the idea behind this proof is to show that orange minus blue is yellow, and orange minus blue is yellow. And since the oranges are equal and the blues are equal, the yellows must be equal. And instead of, it's a lot like our subtraction proof above. So if I highlight it to kind of match, orange is equal to orange. Here's the orange statements. This is AC, and this is DF. So the circle and the rectangle must be the same. And then because both of them had the blues within them, I subtracted the blue out of each, and I was left with BC equals EF. So check that out, use the references, and these proofs will take time, and we're doing similar proofs in class tomorrow.